Hi, Bill McGuire from Tutor 1 here. Today we're going to look at solving equations, manipulating equations, learning how to handle equations easily. Okay? And it's one of the most powerful tools that we can learn in high school. It'll help us in math, help us in chemistry, it's going to help us in physics, it'll help us all the way through university and all those courses. So if you're not really comfortable about handling equations, take a look at this and I hope it helps. Bill McGuire from Tutor 1.
Hi, Bill McGuire here. Today we're going to talk about elementary algebra and solving equations. Okay, so first we have to get some elementary concepts out of the way. The first one is, what is a constant? Okay, a constant, pretty simple term, is simply an integer, a fraction, a real number that doesn't change. Okay, so here are three constants. What's the value of 5 in any given situation? Well, the value of 5 is 5. Okay, what's the value of 4 in any given situation? It's 4. How many fingers should you hold up to represent the number 4? Well, you should hold up 4. 4 is a constant, never changes. 3 is a constant, so is 1.0753. What value does it represent? It represents 1 in 753 ten-thousandths, and it always represents that. Okay, it's a constant. The constant doesn't change. Second term, variable. I ask students all the time what a variable is, and I get all sorts of answers. Mostly I get, I'm not sure. I know what it is, but I can't explain. That's actually the most common explanation for just about every question I ask. Okay, so what is a variable? Well, a variable is simply a letter or symbol that represents a number. Okay, a letter or symbol that represents a number or a quantity. Okay, so for example, we can use the letter A and say that's a variable. So if 3A equals 3, or A equals 3, that must mean that A equals 1. Okay, because A simply represents a number. If it's the number 1, it's 3 times 1 equals 3. So variable is simply a symbol that represents a number, but that's pretty simple. What are the implications of that? Well, the implications of that are that anything we can do to a number, we can do to a variable. For example, if we have 3 outside of 3 plus 1, that's obviously 3 outside of 4, which equals 12. Okay? We can also look at this as 3 times 3 is 9. 3 times 1 is 3. 9 plus 3 equals 12. Okay? Let's look at the same situation with a variable. 3 outside of x plus 1. Well, 3 outside of x plus 1 equals 3x plus 3. We performed exactly the same operation on the variable as we did on the number. How can we get the same number? Well, by putting in the same number for the variable. So if x equals 3, then 3 times 3 plus 3 equals 12. Okay, so those are two basic concepts that we need. We need to know what a variable is. It's something that varies, okay, because we put in a 3 for it, but it could have been x equals 4, could have been x equals 5, could have been x equals anything. Okay. And a constant is something that doesn't change. Okay, where do we go from here? Well, now we have to find out or know what is an equation. Well, what is an equation? An equation is very simple. An equation is anything with an equal sign in it and a true statement on both sides. Two equals 2 is an equation. Okay? You'll notice equation has the word equal in it. Well, almost anyway. 2 equals 2 is an equation. 2x equals 4 is an equation because x could equal 2. In that case, 2 times 2 equals 4. Okay? 3 equals 5 is not an equation because it's not a true statement. Okay, what's the next step? Let's take a look at the equation x plus 3 equals 7. Okay? We all know that the answer is 4, and that's obvious. The question is, how do we find it? To do that, let's think about really what an equation is. And one of the things we can compare an equation to is a balance. If we have a balance, we have 5 kilo on the one side of the balance, 5 kilo on the other side of the balance. The balance stays straight. We had 2 kilo on the left side, the scale moves down. But what happens if we had 2 kilo on the other side at the same time? Nothing changes, correct? Well, if nothing changes, what about if we subtract 5? On both sides, nothing changes. Okay? That's the basic principle we use to solve equations. So what we're going to do with this simple equation is we're going to subtract 3 from this side. We're going to subtract 3 from this side. It doesn't change the equation because the equation is still balanced. But x equals 7 minus 3, which is 4. Okay? Well, that's fairly simple, but so suppose we have x minus 16 equals minus 27. That's a little more difficult to see an obvious answer to, isn't it? Okay, so but what are we going to do? How do we get rid of this 16? Well, we can get rid of it by adding a plus 16 on that side. Of course, to balance the equation, we have to add a plus 16 on this side. Now we get x equals negative 27 plus 16, which is simply negative 11. Okay. Well, that seems pretty straightforward. What's the next step? Well, the next step is, suppose we have 2x plus 7 equals, 17. Okay. Remembering that an equation is a balance, our first step is still to get rid of the 7. We want to get the variable term on its own. Well, if we do that, we have to do this. We have to put a negative 7 on both sides. So now we have 2x equals 17 minus 7, which is 10. Now we can see by looking at that the answer is x equals 5. Okay? But the answer is not always going to be so obvious. So let's see if we can figure out a method to get that easily. Straightforward method is simply to divide by 2. Dividing by 2, we get an x equals 10 over 2, which equals 5. Okay, that method works very well for a lot of equations. But let's look at another definition and see if we can figure out a way that's going to be more powerful and useful. Okay, another definition is reciprocal. What is a reciprocal? Okay. Definition of reciprocal is, again, fairly simple definition. Any two numbers multiplied together that equal positive 1. Okay. Any two numbers multiplied together that equal positive 1. Obvious example is 1 times 1, which equals positive 1, and negative 1 times negative 1, which equals positive 1. Well, what's the reciprocal of 1/2? Well, the reciprocal of 1/2 is 2 over 1. 1 times 2 is 2. 1 times 2 is 2. We get 2 over 2, which equals 1. Reciprocal of negative 3 over 4 is negative 4 over 3. Negative times a negative is a positive. 3 times 4 is 12 over 3 times 4 is 12 equals positive 1. So we can see, looking at these three examples, that a reciprocal is simply the inverse of the number we're trying to get the reciprocal of. So if we have, say, negative 347 x equals 12. Suppose we want to take the reciprocal of negative 347. Well, all we do is 1 over negative 347. But this is an equation which is balanced, so we have to do the same thing to the other side. 1 over negative 347. So 1 over negative 347 times negative 347 is simply 1x, which can be written as x, equals negative 12 over 347, which is our answer. Okay. Going back to this simple example, we have 2x equals 10. Take the reciprocal of whatever it is we want to get rid of, in this case the 2. Because it's a balance, we have to do the same thing on the other side. And we end up with x equals 10 over 2, which equals 5. Although it seems like these two are the same, and they are in a way, using reciprocals is just as easy and a lot more powerful, because we can use it in a situation like this. Okay, now we can simply divide both sides by negative 3/4 and come up with an answer, but we do it more conveniently by going minus 4 over 3, which is a reciprocal. Same thing on the other side, because we have to, because an equation is a balance. And we get x equals 275 times 4 over 3, and the sign of that term is negative. Okay, what are some other things we can look at? Well, let's take a look at 3x minus 5 equals 7x plus 7. Okay, this looks a little bit different than previous equations, but what we have to do here is group terms. In this case, I want to move the 3 to the other side. I want to move the 7 to this side. So I subtract 3x from both sides. I subtract 7 from both sides. I end up with minus 12 on the left side. I end up with 4x on the right side. I take the reciprocal of what I want to get rid of. I take the reciprocal, I have to do the same thing on the other side, and I get x equals minus 12 over 4, which equals minus 3. Okay. Suppose I have 3 over x equals 17. Okay, as you can see, the x is on the bottom. So it says if we just got rid of the 3, we'd be solving for 1 over x, not x. We're trying to solve for x. We want to find out what x is, okay? So if we've got a situation like this, we've got a ratio. And we can simply flip those upside down to get the x in the correct position. So now we've got x over 3 equals 1 over 17. We can now get rid of the 3 on the bottom by using the reciprocal, which is 3 over 1. And we end up with x equals 3 over 17. Okay? What's another way we could have done that? Well, let's look at it just using reciprocals. Once again, the x is on the bottom. We need to get it on the top to solve for x. So we're going to use the reciprocal of what it is we want to move. In this case, we want to move the x. So we have to multiply both sides by x over 1. That turns that into a 1. So we end up with 3 equals 17x. Now we simply use the reciprocal of what we want to get rid of, which is the 17. We have to do the same thing to the other side. And we end up with 3 over 17 equals x. Okay, that's it for equations for today. I hope it's been helpful. Please send me any comments or questions you have, and I'll be happy to answer them. This is Bill McGuire from Tutor 1.